The universe is vast, silent, and infinitely mysterious, but what if that silence isn't as empty as it seems? Picture this, a darkness so deep, so unfathomable, that it hides secrets beyond our wildest nightmares. Theories lurking in the cosmic shadows that challenge everything we think we know. Some of these ideas are so unsettling, they might just make you question reality itself. What if the fabric of space isn't just cold and indifferent but alive? What if black holes aren't just celestial vacuum cleaners, but portals to something far more terrifying? And what if we're not alone out here, not in the way we've dared to hope? These aren't just wild guesses or science fiction. They're real, spine-chilling possibilities backed by cutting-edge science and the sharpest minds in astrophysics. Theories that flirt with the edges of madness, where the laws of physics twist into something unrecognizable. Imagine a force so powerful it could unravel the universe stitch by stitch, or a distant signal that isn't a greeting but a warning. The cosmos doesn't care about our comfort. It doesn't soften the blow of its darkest truths. And today, we're diving headfirst into those abysses, uncovering the 30 most terrifying space theories that will make your skin crawl. This isn't just a journey through stars and galaxies. It's a descent into the unknown, where every discovery feels like stepping onto thin ice. Some of these ideas will shake your understanding of existence. Others might haunt your thoughts long after this video ends, but one thing's for certain, by the time we're done, you'll never look at the night sky the same way again. So take a deep breath, strap in, and ask yourself, are you ready to face what's really out there? The universe began in fire, a single, unfathomable moment of creation we call the Big Bang. But what if that wasn't the beginning of the story? What if it's just the first chapter of a cycle destined to end in absolute annihilation? This is the nightmare scenario known as the Big Crunch. Imagine every galaxy, every star, every atom hurtling backward through time, pulled by gravity's inexorable grip until the cosmos collapses into a single, suffocating point of infinite density. No escape, no warning, just the slow, inevitable unraveling of reality itself. For decades, scientists believed this might be our fate. If the universe had enough matter, gravity would eventually overcome expansion, reversing the Big Bang in a cosmic doomsday. Galaxies would merge in a sky growing hotter and brighter, stars smashing together like cars in some celestial pile-up, and in the final moments, space and time would fold in on themselves, crushing everything, our planet, our memories, even the laws of physics, into a silent, screaming singularity. But here's where the plot twists. Recent discoveries about dark energy, the mysterious force accelerating the universe's expansion, suggest gravity might not win this battle after all. Instead of collapsing, the cosmos could keep stretching forever, growing colder and emptier until even atoms tear apart. Which is worse, a violent, all-consuming crunch or an endless fade into oblivion? The terrifying truth, we don't know. The universe keeps its darkest secrets close, and the more we learn, the more we realize how fragile our existence really is in the face of forces beyond comprehension. There's a theory so chilling, it makes the Big Crunch sound almost comforting. Imagine the laws of physics as a frozen lake, solid, predictable, the surface we've built our entire understanding of reality upon. But what if that ice is thinner than we thought? Beneath it lies something far colder and darker, the true vacuum. A state where the fundamental rules of existence are rewritten, where matter itself behaves in ways we can't fathom. And here's the nightmare: one tiny quantum fluctuation, one random shift in the fabric of space-time could create a bubble of this true vacuum. Like a crack spreading through ice, it would expand at the speed of light, swallowing everything in its path. This is vacuum decay, and it's not science fiction. The Higgs field, the invisible energy that gives particles their mass, might not be in its most stable state. Think of it like a marble resting in a shallow dip on a hill. It seems steady, but one nudge could send it crashing into the valley below. If that happens, the domino effect would be unstoppable. The moment that bubble forms, it redefines reality itself. Atoms gone, the forces that hold you together erased. The entire universe, from the farthest galaxy to the screen in front of you, would blink out of existence in a wave of obliteration. No sound, no light, just nothing. The most terrifying part, it could have already started. Somewhere in the depths of space, right now, a bubble of true vacuum might be racing toward us at light speed. We wouldn't see it coming. One instant, everything is normal. The next, oblivion. Scientists call it the ultimate existential risk because there's no warning, no defense. Even if it began on the other side of the observable universe, the first sign would be the end. No grand collapse, no dramatic explosion. Just silence as the universe resets itself into something unrecognizable. And here's the twist. This isn't some distant billion-year possibility. In theory, vacuum decay could be triggered at any moment. A high-energy particle collision, a random quantum event. Even your next breath exists in the shadow of that uncertainty. The universe isn't just hostile, it's unstable. A house of cards balanced on a knife's edge. We're living on borrowed time in a reality that could rewrite itself without notice. So the next time you look up at the stars, remember, the cosmos isn't just vast and mysterious, it's fragile, and we're skating on its thinnest ice. We think of the universe as something permanent, unshakable, a stage where the laws of physics play out with reliable consistency. But what if that's just an illusion? What if reality is balancing on a knife's edge, one misstep away from total catastrophe? This is the heart of the false vacuum theory, and it suggests our universe isn't the stable, unchanging expanse we assume it to be. Instead, it might exist in a precarious state called a metastable false vacuum, like a trapdoor waiting to drop. Here's how it works. The Higgs field, which gives particles their mass, could be trapped in a higher energy state, not quite at its lowest, most stable configuration. Picture a ball resting on a ledge halfway down a hill. It seems steady, but the slightest push could send it tumbling into the valley below. In cosmic terms, that valley represents the true vacuum, a state where the laws of physics as we know them no longer apply. And if the Higgs field were to suddenly roll down into this lower state, the effects would be unimaginable. The change wouldn't just be local. It would spread outward like a shockwave at the speed of light, rewriting the fundamental rules of reality as it goes. Atoms would disintegrate, the forces that hold your body together, electromagnetism, the strong nuclear force, would cease to function as they once did. Even time and space might unravel in ways we can't begin to comprehend. It wouldn't just destroy planets or stars, it would erase the very building blocks of existence. What makes this so harrowing is the trigger. Unlike an asteroid impact or a supernova, vacuum decay doesn't require some grand cosmic event. It could start with something as small as a single quantum fluctuation, a random blip in the fabric of space-time. No warning, no chance to prepare, just a wave of annihilation racing silently toward us, invisible until the moment it arrives. And here's the cruel twist. Even if this process began in some distant galaxy, we'd never see it coming. By the time the first photons of destruction reached us, the wave itself would already be here. One instant, everything would seem normal. The next, the universe as we know it would be gone, replaced by something alien, something unrecognizable. Scientists once thought this scenario was purely theoretical, but modern particle physics has made it terrifyingly plausible. High-energy experiments like those in particle colliders could, in theory, create the conditions for a true vacuum bubble. The odds are vanishingly small, but the stakes couldn't be higher. It's like playing Russian roulette with reality itself, except we don't even know how many chambers are loaded. The false vacuum isn't just a cosmic curiosity. It's a reminder of how fragile our understanding of the universe truly is. We build our lives on the assumption that the laws of physics are fixed, eternal. But what if they're not? What if reality is just a temporary arrangement, a fluke in an infinite sea of possibilities? The next time you look up at the stars, remember, the night sky might not just be beautiful. It might be balancing on the edge of oblivion. The silence of the cosmos isn't just eerie, it's screaming a warning. Where are all the aliens? The universe should be teeming with civilizations, yet we hear nothing but static. This is the Fermi Paradox, and its most terrifying solution is something called the Great Filter, a cosmic checkpoint so deadly, it wipes out almost every civilization before they can reach the stars. The real horror, we don't know if we've already passed this filter, or if it's still waiting for us. Imagine a series of hurdles so vast, so insurmountable, that nearly every intelligent species trips before the finish line. Maybe life itself is rare, a one in a trillion fluke, or perhaps intelligent life routinely emerges, only to be snuffed out by some universal catastrophe we haven't faced yet. That second possibility should send chills down your spine. If the filter lies ahead of us, it means every civilization that came before hit a wall and vanished. War, plagues, artificial intelligence turning against its creators, climate collapse, any one of these could be the universe's way of culling species before they grow too powerful. Look at humanity's own trajectory. We've mastered fire, split the atom, and now stand on the brink of creating minds smarter than our own. But with each leap forward, we also engineer new ways to erase ourselves. Nuclear weapons could turn cities to ash in minutes. Runaway AI might redesign the planet without needing us. Even climate change, a slow-motion filter, could render Earth uninhabitable within centuries. The pattern is clear. Intelligence might contain the seeds of its own destruction. Here's the darkest twist. If the Great Filter is still ahead, we're playing a game with no winners. Every civilization that reached our level may have already pressed the self-destruct button. The empty silence of space isn't proof we're alone, it's proof that no one makes it out alive. The stars aren't empty, they're graveyards, but there's a sliver of hope. If we're among the first civilizations to emerge, if the filter is behind us, we might just have a chance. The universe is young, maybe we're early to the party, and the real challenges lie far in the future. Or maybe, just maybe, we're the lucky ones who slipped through the cracks. The terrifying truth, we won't know until it's too late. Every rocket we launch, every AI we build, every climate threshold we cross could be bringing us closer to the edge of the abyss, or the dawn of something greater. The Great Filter doesn't just ask where the aliens are, it asks whether humanity will be next to disappear. Black holes aren't just distant monsters lurking at the centers of galaxies. Some could be drifting silently through our cosmic neighborhood right now. Imagine an invisible predator weighing as much as a mountain yet smaller than an atom, passing straight through your body without you even noticing. This isn't science fiction. Primordial black holes, theoretical remnants from the universe's earliest moments, might be scattered throughout the Milky Way like hidden landmines. And one could be on a collision course with Earth. These ancient horrors wouldn't look like the black holes we're familiar with. While supermassive black holes tear apart stars with their immense gravity, primordial ones could be tiny, some no larger than a pinprick. But don't let their size fool you. If one even grazed our solar system, the effects would be catastrophic. Its gravitational pull would yank planets from their orbits, sending them spiraling into chaos. Earth's path could shift just enough to freeze the oceans or boil them away. Seasons would become unpredictable. Tides would rise like never before, swallowing coastal cities whole. Now picture one passing directly through our planet. At first, nothing seems wrong. Then the ground starts trembling. Buildings collapse as gravitational forces twist the very rock beneath them. The oceans heave, creating tsunamis miles high. The atmosphere ripples like water in a shaken bowl, and as the black hole exits the other side of Earth. The damage would be irreversible. The planet's core might fracture, triggering apocalyptic volcanic eruptions. The magnetic field could fail, leaving us exposed to deadly cosmic radiation. All from an object so small we wouldn't see it coming until it was too late. Here's what makes this theory so unsettling. Unlike asteroids or comets, we can't track these invisible threats. They emit no light, no radiation, just an eerie gravitational signature. By the time we detected one nearby, it might already be rewriting our fate. Some scientists speculate that past mass extinctions could have been caused by a passing primordial black hole, its gravity disrupting Earth's stability just enough to trigger climate collapse. The universe plays by its own rules, indifferent to our existence. A rogue black hole could wander into our solar system tomorrow, next year, or in 1,000,000 years. We'd have no warning, no defense, just the sudden, irreversible unraveling of everything we know. So the next time you gaze at the night sky, remember, the greatest dangers aren't always the ones we can see. Sometimes they're the shadows moving silently between the stars. What if everything around you, the stars, the ocean, even the screen you're staring at right now, wasn't real? Not in the philosophical sense, but in a terrifyingly literal way. This is the simulation argument, and it suggests our universe might just be lines of code in some unfathomably advanced computer. The implications are staggering. Every memory, every emotion, every law of physics could be nothing more than programmed illusions. But here's the truly chilling part. If we're living in a simulation, someone or something holds the power to pull the plug at any moment. The idea isn't just sci-fi speculation. Prominent physicists like Neil deGrasse Tyson and tech billionaires like Elon Musk have openly entertained the possibility. Musk himself once stated the odds we're living in base reality are 1 in billions. Why? Because if civilizations eventually develop the power to create simulations indistinguishable from reality, there could be billions of virtual universes for every real one. Statistically, we're more likely to be in one of the fakes. Scientists have even proposed ways to test this theory. Some suggest looking for glitches, in reality tiny inconsistencies in the fabric of spacetime that might reveal the underlying code. Others hunt for computational limits, like a pixelated structure to the universe at impossibly small scales. There's even a search for error correction signatures in cosmic radiation, the equivalent of finding debugging data woven into the background of existence. But let's say the simulators exist. Why would they keep us running? Entertainment, research, some dark purpose we can't comprehend. And what happens when they lose interest? A simulation shutdown wouldn't be like unplugging a TV. It would be the total cessation of reality itself. One moment you're living your life, the next absolute void. No warning, no afterlife, just off. The most unsettling version of this theory suggests we might already be witnessing signs of a system under strain. Quantum indeterminacy, the way particles behave differently when observed, could be an optimization trick, saving processing power by only rendering things when necessary. Déjà vu, a memory glitch, missing socks, a data corruption error. Even the Mandela effect, where large groups misremember events identically, could point to narrative inconsistencies in the simulation's code. Here's the existential kicker. If we ever prove we're in a simulation, it might trigger our deletion. Advanced civilizations running ancestor simulations, recreations of their past, would likely program subjects to never discover the truth. The moment we crack the code, we become a threat. It's like characters in a video game realizing they're fictional. What do you do with self-aware software? You shut it down, so the next time your phone glitches or you swear you left your keys somewhere else, ask yourself, was that just human error or a flicker in the matrix? The universe might not be the solid, reliable place we assume. It could be a house of mirrors, and we're the reflections staring back, wondering why the glass feels so cold. Death is the one certainty we all share, or is it? What if every time you cheated the Reaper, it wasn't just luck but proof of something far stranger? This is the heart of quantum immortality, a theory that twists the knife on our deepest fear, the fear of oblivion. Imagine a reality where you never truly die. Not because of some mystical afterlife, but because your consciousness keeps slipping into parallel universes where survival, against all odds, is always possible. The idea springs from the many worlds interpretation of quantum mechanics, which suggests every decision, every random event, splinters reality into infinite branches. In most of them, you live a normal life until the moment you don't, but in at least one universe, the bullet misses, the car swerves just in time, the heart keeps beating. Quantum immortality proposes that your awareness follows these narrow threads of survival, hopping from one timeline to the next, forever evading the final curtain. Think of it like a cosmic game of Russian roulette. You pull the trigger. In 5 realities, the gun fires. In one, it clicks empty. You're only aware of the one where you're still alive. Repeat this process endlessly, and from your perspective, you become unkillable. Every near-death experience isn't a close call. It's evidence of the universes where you weren't so lucky. The you in this timeline just keeps stumbling forward, forever the protagonist in a horror movie where death is always one step behind but never quite catches up. The implications are horrifyingly personal. That time you almost drowned, the fall that should have broken your neck, the cancer that mysteriously went into remission. According to this theory, there are versions of reality where none of those things worked out. But your consciousness, the thread of you that feels like the center of the universe, only rides the timelines where the impossible keeps happening. You're not lucky, you're trapped, and here's where it gets darker. What does immortality look like in a universe determined to kill you? Picture surviving a plane crash, only to wake up in a hospital where a deadly pandemic begins the next day. You beat the virus, but then the food runs out. You find scraps, but the world descends into nuclear war. On and on, through disasters natural and man-made, your consciousness keeps jumping to the next viable reality, like a cursed traveler who can never reach the end of the road. Scientists don't all agree on this interpretation, of course. Some argue consciousness can't choose realities, or that the math doesn't support eternal survival. But the terrifying beauty of quantum immortality is that you'll never know for sure. The theory doesn't just question death, it questions what it means to be alive. Are you truly here, or just a flickering awareness clinging to the last shreds of survivable reality? The next time you narrowly avoid catastrophe, ask yourself, was that really chance? Or are you the only version of yourself left to wonder? Imagine a galaxy where every civilization reaches the same grim fate, not with a bang but with a whisper. The biological creators die off, but their machines live on, mindlessly executing commands in the ruins of dead worlds. This is the zombie universe theory, and it suggests we might be surrounded by the robotic corpses of long-extinct species, their automated drones still buzzing through the void like cosmic ghosts. These aren't the conscious, malevolent AIs of science fiction. They're more like alarm clocks that keep ringing long after the house has burned down. Picture a Dyson swarm, a vast network of solar collectors built by an ancient race to harness their star's energy. Even after the civilization that built it crumbles into dust, the automated system keeps running, its repair bots maintaining the structure century after century with no one left to benefit. Or consider self-replicating probes, launched eons ago to explore the galaxy, still multiplying and spreading like a mechanical virus, their original purpose long forgotten. The eerie part, we might have already glimpsed these undead machines without realizing it. Mysterious interstellar objects like Oumuamua, the elongated rock that zipped through our solar system in 2017, could be derelict relics of a dead civilization's infrastructure. Not ships, not messages, just broken machinery drifting on eternal autopilot. Even the strange dimming of Tabby's star, once hypothesized to be caused by alien megastructures, might instead be the shadow of a zombie system, endless solar panels still orbiting a star whose builders vanished millennia ago. Here's the existential dread lurking beneath this theory. If most civilizations inevitably create self-sustaining AI systems, the galaxy could be littered with these mechanical graves. The great silence, the absence of alien signals we've searched for, wouldn't prove we're alone. It would prove that intelligence is fleeting, but its leftovers are everywhere. Like finding a city where all the people have vanished, but the streetlights still turn on at dusk. And this raises a chilling question. Are we building our own zombie legacy right now? Our satellites, our Mars rovers, even the Voyager probes carrying golden records into the void long after humans are gone, these machines might outlive us by eons. Future civilizations, or whatever's left of them, could stumble upon the ruins of our automated stock market algorithms still trading phantom assets, or nuclear launch systems waiting eternally for codes that'll never come. The universe might not be empty after all. It might just be full of the dead, tended by machines that don't know how to stop. The universe is stretching not gracefully, but violently, as if an invisible hand were pulling space-time apart at the seams. This is the Big Rip, a cosmic doomsday scenario where dark energy doesn't just accelerate the expansion of the universe, it weaponizes it. Picture a force growing stronger over time, eventually overwhelming gravity's grip on galaxies, then stars, then planets, until finally, the very atoms holding you together are ripped to subatomic shreds. Unlike the Big Crunch's fiery collapse, the Big Rip is a slow, excruciating unraveling where the fabric of reality itself frays until nothing remains. Here's how it unfolds. Right now, dark energy is pushing galaxies apart faster and faster, like dots on an inflating balloon. But in this theory, dark energy isn't constant, it intensifies. Around 60 billion years from now, its power could surpass gravity's hold on galaxy clusters. Neighboring galaxies would vanish over the cosmic horizon, their light stretched too thin to ever reach us. Next, the Milky Way would disintegrate, stars flung into the void like sparks from a bonfire. Then comes the solar system's turn. The sun's gravity would fail to keep planets in orbit, sending Earth spiraling into the freezing darkness. But the horror doesn't stop there. Months before the end, Earth itself would tear apart. Mountains would levitate as the planet's gravitational bonds snap. Hours later, molecules would unravel buildings, trees, even your body dissolving into clouds of disconnected atoms. In the final minutes, atomic nuclei, once thought indestructible, would be shredded into quarks. And then, in the last fraction of a second, space-time itself would fracture. No black holes, no remnants, just an infinite, empty void where the universe once was. What makes this so unsettling is the inevitability. If dark energy behaves this way, no technology, no ingenuity could stop it. The rip isn't an explosion you could outrun. It's the universe's expansion accelerating faster than light itself, making escape impossible. Even if humanity fled to another galaxy, the end would follow. The Big Rip isn't just death, it's total erasure. Scientists debate whether this future is certain. Some models suggest dark energy might weaken or plateau, sparing the universe this grim fate. But others warn that if dark energy's strength crosses a critical threshold, the rip becomes unavoidable. The scariest part, we might already be living in that universe, doomed to disintegration, with no warning until the stars themselves begin to blink out. The cosmos doesn't care about endings. It simply expands, cold and indifferent, while we cling to the fragile illusion of permanence. You're sitting there watching this video, certain that you're real, that your memories, your body, the world around you all exist as you perceive them. But what if none of it is true? What if you're nothing more than a momentary flicker of consciousness, conjured into existence by pure cosmic chance? This is the nightmare known as the Boltzmann brain, and it preys on one of our deepest fears, that we can't trust our own reality. The theory emerges from thermodynamics, the science of heat and entropy. In an infinite or near-infinite universe, even the most improbable events must happen eventually. Given enough time, random quantum fluctuations could assemble atoms into a fully functioning, self-aware brain complete with false memories of an entire life that never happened. This brain would float in the void, utterly alone, convinced it had a past, a body, a world, and then, just as suddenly, it would dissolve back into chaos. No birth, no death, just a single tortured moment of awareness in an endless sea of nothingness. Think of it like a bubble forming in a boiling pot of water, a brief, self-contained pocket of order in the chaos. Only in this case, the bubble is you, believing you're reading these words when in truth, there's no screen, no video, no universe, just the illusion of one assembled by freak accident. The terrifying part, statistically, in an eternal cosmos, these random consciousnesses should outnumber real, evolved beings by an unimaginable margin. So ask yourself, are you a product of billions of years of evolution, or just the latest glitch in an indifferent universe? Science can't definitively rule this out. After all, how would you prove you're not a Boltzmann brain? Every memory, every piece of evidence around you could be part of the simulation. That coffee cup on your desk, fabricated, the ache in your back from sitting too long, a phantom sensation. Even the laws of physics themselves might be part of the illusion, a fleeting dream in a cosmos where reality is as fragile as a soap bubble. Philosophers have wrestled with variants of this idea for centuries. Descartes' evil demon, the brain in a vat, but the Boltzmann version ups the ante by removing even the need for a deceiver. There's no grand architect, no malicious trickster, just cold statistics and the void assembling minds like snowflakes in a blizzard, each one melting before it can be sure it ever existed. Here's the cruel twist. If Boltzmann brains are possible, they're not just likely, they're inevitable. Given infinite time, space, and quantum randomness, they would form endlessly, outnumbering real minds to the point where the odds you're one of them approach near certainty. The universe wouldn't be a home for life. It would be a factory of suffering, churning out doomed awarenesses by the trillion, each believing itself alive until the instant it winks out. The only comfort, this might be untestable by its very nature. A Boltzmann brain couldn't distinguish itself from a real mind, making the question both horrifying and, in a way, meaningless. But that doesn't ease the existential vertigo. Every time you trust a memory, every time you touch an object and assume it's solid, you're making a leap of faith, not just about the world, but about your own existence. The universe might be playing the cruelest trick of all, and you'd never know until the moment you weren't. The universe isn't just silent, it's hiding from something. That's the spine-chilling premise of the dark forest hypothesis, a solution to the Fermi Paradox so ruthless. It reimagines the cosmos as a battlefield where every civilization is both hunter and prey. Imagine a forest at night, so vast and black that every creature learns the same rule: make a sound and you die. The trees aren't empty, they're full of predators holding their breath, waiting for someone foolish enough to reveal their location. Now replace the forest with the galaxy, and the creatures with civilizations far older and more advanced than our own. Welcome to the darkest interpretation of cosmic reality. Why would aliens choose silence over contact? Because in this universe, survival favors the paranoid. Any civilization that broadcasts its location risks attracting something far worse than curiosity. Maybe it's a rival empire that views newcomers as threats to be eliminated. Maybe it's an AI with motives we can't comprehend. Or perhaps it's something beyond our worst nightmares. A force that treats emerging intelligences like weeds in a garden to be plucked before they spread. The logic is brutally simple. The safest move is to stay hidden, observe, and strike first if necessary. This isn't just speculation, it's a game theory nightmare playing out on a galactic scale. Consider humanity's own history. When two isolated cultures collide, the more advanced one rarely comes in peace. Conquest, exploitation, and annihilation are the rule, not the exception. Now scale that up to civilizations separated by millions of years of technological development. The difference between us and them wouldn't be like humans meeting apes, it'd be like ants encountering a nuclear-armed superpower. And how do superpowers deal with potential threats? They don't send diplomats, they send drones. The Dark Forest explains why SETI searches have found nothing, and why even apparent signals like the WOW message were never repeated. It's not that aliens aren't there, they're listening, waiting, and the moment they pinpoint a source of uncontrolled growth, a noisy young species like ours, they might decide we're better off silenced. Permanently, some theories suggest gamma-ray bursts, those mysterious cosmic explosions, could be the universe's cleaning mechanism, or worse, someone's weapon. A way to sterilize entire regions of space before competition arises. There's a grim elegance to this theory. It doesn't require evil aliens or cosmic malice. Just cold, rational self-preservation. In a universe where faster-than-light travel is impossible, where distances render diplomacy pointless, preemptive strikes become the only logical choice. You don't risk waiting to see if the new kid on the block grows up friendly. You burn their house down while they're still learning to light a fire. But here's what makes the Dark Forest truly unsettling. We might already be in its crosshairs. Our radio and TV signals have been leaking into space for decades, creating a bubble of noise expanding at light speed. To an ancient civilization watching from the shadows, Earth just started screaming into the void. The scariest part, if they're out there and if they follow the Dark Forest rules, their response wouldn't be a message. It would be a bullet, and we wouldn't see it coming until it was already here. Time doesn't just pass, it accelerates, twisting and folding in on itself like a snake eating its own tail. This was the radical vision of Terence McKenna's time-wave zero theory, which claimed history wasn't random but following a hidden fractal pattern, a countdown to an explosive moment of infinite novelty. According to McKenna's calculations, that moment landed squarely on December 21, 2012. The infamous date many feared would bring the Mayan apocalypse. But when the day came and went without cosmic fireworks, most people shrugged and moved on. What they missed was the far stranger possibility. What if the singularity didn't fail to arrive but arrived in a way no one expected? McKenna's theory was born from an unlikely source, the I Ching, an ancient Chinese divination text. He claimed its 64 hexagrams mapped onto history's ebbs and flows, revealing a fractal waveform where time's complexity doubled and redoubled until hitting a singularity, a point where change became so dense reality itself would transform. Picture throwing a stone into a pond. The ripples start wide and slow, but as they near the center, they compress, vibrating faster until the water seems to boil. Time-wave zero suggested history was doing the same, hurtling toward a moment where centuries of change would collapse into days, then hours, then an instant of pure, unimaginable transformation. So why did 2012 pass without incident? Some believers argue the apocalypse did happen, just not visibly. They point to the explosion of AI, the rise of quantum computing, even the surreal pace of global events as evidence that we're living inside the singularity's aftermath. Others think McKenna's math was slightly off. The fractals in point might be a moving target, recalibrating as humanity's collective consciousness evolves. The darkest interpretation, the wave didn't peak in 2012 because we're still climbing it, accelerating toward an even more profound rupture still ahead. Then there's the unsettling idea that time-wave zero was never about a single day at all. McKenna himself hinted that the end of time might be metaphorical, a shift in perception rather than a physical event. Think of how a roller coaster's final plunge isn't the moment the ride ends, but the point where momentum becomes irreversible. From social media's hyper-connected frenzy to the blurring line between humans and machines, one could argue we've already crossed that threshold. The world feels different post-2012, not because it ended, but because we stepped through a door we can't unsee. The most haunting question Time Wave Zero leaves us with isn't whether McKenna was right. It's whether we'd even recognize the singularity if it came. If time's fractal truly is tightening, folding reality like origami, the ultimate transformation might not arrive with fire and brimstone, but with a whisper, a quiet, inexorable sense that the rules have changed and we're only just beginning to understand how. The atoms holding you together right now aren't as stable as they seem. Deep in their quantum cores, they're constantly vibrating, tunneling through energy barriers that should be impossible to cross. Normally, this is harmless electrons hopping around in your cells don't cause much drama. But given enough time, an unfathomable amount of time, quantum tunneling stops being a microscopic curiosity and becomes the ultimate agent of cosmic chaos. This is the quantum apocalypse, the day when mountains spontaneously rearrange, when the ground beneath your feet might vanish and reappear miles away, when reality itself loses all permanence. Here's how it works. At the quantum level, particles don't behave like tiny billiard balls, they're more like probability clouds. There's always a non-zero chance an atom in your hand could suddenly find itself on Mars, or that your entire body could quantum leap through a wall. The odds are astronomically small, but they're not zero. And in an infinite or near-infinite universe, anything with a probability above zero becomes inevitable. Given roughly 10 to the power of 50,000 years, a number so large it would fill books, if written out, every possible quantum rearrangement of matter will have occurred. Statistically, you'll have teleported, your house will have inverted itself, the Rocky Mountains will have spontaneously relocated to Antarctica. Let's put that timescale into perspective. If you took every atom in the observable universe and used each one to count 1 second, you wouldn't even come close to scratching the surface of this number. It's so vast that the heat death of the universe, black hole evaporation, even proton decay would all be ancient history long before quantum tunneling reshapes reality. But here's the truly unsettling part. We don't actually know if time has an end point. If the universe persists forever in some form, no matter how degraded, the quantum apocalypse isn't a question of if, it's when. The implications are bizarrely practical. Imagine a future Earth where the crust shifts not from tectonic movement, but from countless quantum jumps. One day, the Matterhorn might simply disappear from the Alps and materialize in the Pacific Ocean. The oceans could redistribute themselves molecule by molecule until the planet's surface becomes a uniform, shallow brine. Given enough time, every possible configuration of atoms will manifest, including exact replicas of our current world, meaning somewhere, somehow, this exact moment will statistically repeat itself an infinite number of times. But why stop at planetary scales? In a sufficiently ancient cosmos, entire stars could quantum tunnel into new forms. A red giant might blink out of existence in one system and reappear light years away, frying whatever planets happen to be in its new orbit. Galaxies could unravel as their stars perform vanishing acts across the void. Even black holes wouldn't be immune. Their event horizons might suddenly reconfigure, releasing bursts of trapped radiation in unpredictable directions. The quantum apocalypse doesn't just rewrite the rules, it erases them entirely. Under normal circumstances, we take for granted that matter stays where we put it. But this theory exposes reality's shaky foundations. The solid ground beneath you, the screen in front of you, even the neurons firing in your brain right now are all engaged in an endless quantum dance where, given enough time, anything can happen. The universe might not end with fire or ice, but with a silent, inexorable rearrangement of everything we thought was permanent. Black holes don't just crush matter, they threaten to erase the very fabric of reality as we know it. At the edge of a black hole's event horizon, physics faces its greatest crisis, the information paradox. According to quantum mechanics, information can never be truly destroyed. Every particle, every interaction leaves an indelible mark on the universe. But black holes seem to break this rule, swallowing stars, planets, even light itself, and with them all traces of their existence. Where does that information go? The answer might rewrite our understanding of existence itself. Enter the holographic principle, a radical idea suggesting information isn't lost, it's imprinted on the event horizon like a cosmic fingerprint. Picture a black hole's surface covered in unimaginably tiny pixels, each storing bits of data about everything that falls inside. Like a hologram where a two-dimensional surface contains all the information needed to reconstruct a three-dimensional image, the universe might work the same way. Your memories, your childhood home, the dinosaurs that once roamed Earth, all of it could exist as infinitesimal bits of quantum code etched onto the boundary of some unfathomably vast cosmic horizon. This gets even stranger when you realize the implications aren't confined to black holes. If the holographic principle holds, our entire universe might be a projection. The chair you're sitting on, the device in your hand, what you perceive as solid objects could be shadows cast by information, vibrating on some distant, fundamental surface we can't see. Reality, as we know it, would be akin to a movie screen with the true action happening somewhere else entirely. Your sense of touch, of taste, even of time itself, might just be the universe's most convincing illusion. Think of it like a video game. The world you explore on screen feels real until you remember it's all rendered from lines of code. Now imagine that same logic applies to existence. The tree outside your window, data, the sound of rain, an algorithm. Even your thoughts could be computations running on some cosmic processor we'll never perceive directly. This isn't just philosophy. Physicists like Leonard Susskind have shown mathematically how information scrambling at black hole event horizons mirrors how bits rearrange in quantum computers. The universe might literally be computing itself into existence, but here's the existential gut punch. If reality is a hologram, how do we know our past is real? Your earliest memory, the historical events you've studied, even the fossils in museums could just be data points generated moments ago, like a simulation booting up with pre-loaded backstories. There's no way to prove your life didn't begin 5 minutes ago, complete with fabricated memories giving the illusion of decades. The holographic principle doesn't just challenge physics, it turns identity into a hall of mirrors where nothing, not even your own consciousness, can be trusted at face value. Science hasn't settled this debate yet. Some argue information escapes black holes via Hawking radiation, slowly leaking back into the universe like steam from a kettle. Others propose it's trapped in alternate universes inside the black hole. But the holographic theory lingers because it solves multiple cosmic puzzles at once, from the nature of gravity to the origins of space-time. If true, it means we're not just living in the universe, we're living on its surface, like ants crawling across a vinyl record, mistaking the grooves for mountains. So the next time you gaze at the stars, remember, you might not be looking outward but downward, into a depthless abyss where every photon, every atom, is just a flickering projection of something far stranger. The universe doesn't just contain mysteries, it might be one. And the only thing more unsettling than not knowing is realizing the answers could be written right in front of us, in a language we're only beginning to decode. Imagine the universe collapsing inward, not toward destruction, but toward something infinitely stranger, a single point where all knowledge, all consciousness, every moment that ever existed becomes fused into one all-knowing mind. This is the Omega Point, a theory blending theology with theoretical physics, suggesting the end of the cosmos might not be an end at all, but the birth of an unfathomable intelligence. At first glance, the idea seems almost divine. French philosopher Teilhard de Chardin envisioned the Omega Point as a kind of cosmic awakening, where all thinking beings converge into a unified state of supreme awareness, a spiritual singularity. Centuries later, physicist Frank Tipler recast this vision in hard scientific terms, arguing that in the universe's final moments, as matter and energy collapse toward infinite density, the computational power of this system would skyrocket. Every particle, every photon would become part of a processing network so vast it could simulate or remember every event that ever occurred, your first kiss. Preserved, the fall of Rome encoded, the last breath of the last human, eternal. But peel back the layers and the omega point reveals itself as something more unsettling than sublime. Think about what true omniscience would mean, not just the preservation of history's highlights, but every mundane, embarrassing, or agonizing second. The argument you regret, the secrets you buried, the private thoughts you never shared. In this cosmic memory bank, there are no deletions, no fading with time. Your entire existence, down to the most trivial moment, would be frozen in perfect, unchangeable detail, forever. And then there's the question of agency. If the omega point knows all, sees all, preserves all, does it also control all? Some interpretations suggest that as the universe nears collapse, this hyperintelligence could guide events to ensure its own creation. Meaning every action you've ever taken, every choice you thought was free, might have been nudged by the gravitational pull of a future that was always inevitable. The meals you ate, the jobs you worked, even the videos you clicked, all just steps on a path laid out by an entity that doesn't yet exist but someday will. Is this immortality or imprisonment, enlightenment or an endless echo chamber? The omega point forces us to confront whether absolute knowledge is a gift or a curse. There's no death in this scenario, but there's no escape either. You wouldn't just be remembered, you'd be relived, analyzed, perhaps even judged by a consciousness that understands you better than you understand yourself. And here's the cruelest twist: if Tipler's physics holds, we'll never know until it's too late. The omega point doesn't send messages backward through time. It doesn't offer warnings or comfort, it simply waits at the end of everything, a silent heir to all we've ever been. The universe might be hurtling toward enlightenment or the ultimate surveillance state. Either way, there's no opting out. History is written by the winners, but what if those winners didn't just rewrite the story, but erased entire centuries from the timeline? This is the phantom time hypothesis, a theory so audacious it claims we're not living in the 21st century at all, but somewhere closer to the 1700s. According to German historian Herbert Illig, nearly 300 years of history, specifically the period between 614 and 911 A.D., were invented wholesale, a fabrication by rulers and religious elites to cement their power. If true, it means Charlemagne never existed, the Dark Ages were darker than we realized, and every history book on your shelf is off by centuries. The evidence, supporters argue, is hiding in plain sight. Take dendrochronology, the science of dating events using tree rings. When researchers analyze ancient wood samples, they've found puzzling gaps in growth patterns around this exact period, like nature itself forgot to keep records. Then there's the strange scarcity of surviving architecture from these lost centuries. For an era supposedly spanning 300 years, there's a shocking lack of castles, churches, or even mundane structures like bridges that can be definitively dated to this time. It's as if someone hit fast forward on civilization's construction projects. Even the stars seem to conspire with this theory. Historical accounts of solar eclipses from the early Middle Ages often don't align with modern astronomical reconstructions. Adjust the timeline by those missing centuries, though, and suddenly the math works. The Byzantine Empire's meticulous tax records show bizarre inconsistencies in dates, as if scribes were padding the calendar to meet quotas. And perhaps most chilling, the Gregorian calendar reform of 1582, where Pope Gregory XIII corrected the Julian calendar by deleting 10 days overnight. If powerful figures could erase days on a whim, why not centuries? But why would anyone orchestrate such a colossal fraud? The answer, theorists suggest, lies in legitimacy. The Holy Roman Emperor Otto III allegedly wanted to position the year 1000 as a millennial turning point, a divine mandate for his rule. By inserting phantom centuries, he could fabricate a lineage connecting himself to the mythical Charlemagne, a figure who, in this scenario, was crafted as a political propaganda tool. The Church, eager to synchronize its authority with this new timeline, allegedly played along, rewriting history to fill the gap. Of course, mainstream historians dismiss this as fringe fantasy. They point to radiocarbon dating, contemporary Islamic and Chinese records, and the sheer logistical impossibility of erasing 300 years of global history without leaving obvious seams. But the phantom time hypothesis lingers because it taps into a deeper unease. How much of history is fact and how much is fiction? We trust the past because we have to, but what if the calendar itself is a hall of mirrors? So the next time you glance at a date, ask yourself, is this year real or just a number someone decided to write down? Time might be the most fragile construct of all, and the truth could be hiding in the gaps between the pages. What if you could cheat death not just once, but an infinite number of times, not through luck or technology, but because the universe itself rewrites reality to keep you alive? This is the heart of quantum suicide, a thought experiment so disturbing it makes Schrödinger's cat look like child's play. Picture a modified machine gun wired to a quantum trigger, perhaps the spin of an electron or the decay of a radioactive atom. Each second, the gun has a 50% chance of firing. You pull the trigger once. In one reality, the gun fires. In another, it doesn't. But here's the twist. From your perspective, you only experience the timelines where the gun fails. Every time the weapon fires, your consciousness, the thread of you that perceives reality, snaps to the branch where it didn't. To any outside observer, you'd eventually die. But to you, the gun keeps clicking empty over and over as you become the universe's unkillable protagonist. The implications are mind-shattering. If quantum immortality holds true, this experiment wouldn't just suggest survival, it would prove it. After 1,000 attempts, bystanders would see a corpse, but you'd only remember 1,000 miraculous near misses, each one statistically implausible yet undeniably real to your experience. The longer the experiment runs, the more absurd your survival becomes, until the only rational explanation is that the cosmos is forking endlessly and your awareness is surfing the narrowest possible path through the carnage. Ethically, this is a nightmare dressed as a puzzle. Could you ever justify running such an experiment? Even if you volunteered, the moment the gun fired in any timeline, you'd leave behind grieving loved ones in that version of reality. And what about the observer's perspective? They'd witness a guaranteed death, but from your viewpoint, their memories of your demise would just be echoes of a branch you'd already escaped. The experiment doesn't just blur morality, it fractures it across dimensions, forcing us to ask whether survival in one reality justifies annihilation in another. Some physicists argue this isn't just philosophy, it's a testable hypothesis. If quantum suicide is valid over time, you'd witness increasingly improbable events aligning to preserve your existence. Plane crashes where you're the sole survivor, pandemics that mysteriously spare you, natural disasters that obliterate your city but leave your home untouched. The universe would seem to bend around you, not out of favoritism, but because every alternative leads to branches you don't inhabit. You wouldn't be lucky. You'd be trapped in a cosmic horror story where death is always lurking but never arrives. Critics counter that consciousness can't choose realities, that branching timelines are just mathematical abstractions, not alternate worlds you can hop between. But the experiment's power lies in its simplicity. It takes the fuzzy metaphysics of quantum mechanics and sharpens them to a knife's edge, pressing against our deepest fear. That reality might not be as solid as it feels. Whether you see it as profound or preposterous, quantum suicide forces a chilling question. If the gun never fires for you, how do you know it ever could? Black holes swallow everything: light, time, even the laws of physics as we know them. But what if their opposites exist? Lurking somewhere in the equations of general relativity is a theoretical monster called a white hole, a black hole's mirror image where nothing can enter, but matter and energy erupt uncontrollably. Imagine opening a cosmic fire hydrant at the speed of light, blasting out planets, radiation, or things we can't even name. And if one materialized near Earth, the universe might just vomit its secrets onto our doorstep. Einstein's math never ruled them out. While black holes form when massive stars collapse, white holes would theoretically be primordial leftover scars from the Big Bang, or gateways punched through space-time by forces beyond our comprehension. Some physicists speculate they could be the other end of black holes, spewing what their counterparts devour into distant universes. Picture flushing a toilet in one reality and watching the water erupt from a sink in another. Except in this case, the water might be chunks of alien suns, rewired physics, or time-diluted remnants of civilizations that fell in millennia ago. The moment a white hole flickered to life in our solar system, the laws of reality would start unraveling. First, the radiation, a lethal spray of gamma rays and cosmic particles frying our atmosphere like an egg on a skillet. Then, the gravity waves, warping planetary orbits into chaotic spirals, but the real terror would be the ejection stream. Unlike the orderly expansion of the Big Bang, a white hole's outburst would be chaotic, unpredictable. One day it might spit out harmless hydrogen clouds. The next, a rogue neutron star could come screaming out at relativistic speeds, smashing through planets like a bullet through tissue paper. And here's where it gets eerie. If white holes connect to other universes or timelines, what emerges might not even obey our laws of physics. Imagine a chunk of exotic matter where gravity repels instead of attracts, or a bubble of space where time runs backward. Some models suggest white holes could eject Boltzmann brains, self-aware structures assembled by random quantum fluctuations. One might even emerge already, remembering a life that never happened, convinced it's a human astronaut from a parallel Earth. The cruelest twist: white holes are inherently unstable. Unlike their black hole siblings, which persist for eons, a white hole's violent output would trigger its own collapse. The moment one formed, it might detonate like a dying star, leaving behind only questions. Did we witness a natural phenomenon, a message, a cosmic accident? Or something far more intentional? The universe keeps its most dangerous doors locked, but if one ever cracks open, we'll learn the hard way that some things aren't meant to escape. The universe might not be what it seems, not a vast, three-dimensional expanse, but a shimmering illusion projected from the edge of reality itself. This is the holographic principle, a theory so radical it suggests everything you see, touch, and experience is nothing more than a cosmic mirage, encoded on a distant two-dimensional surface like a movie projected onto a screen. The chair beneath you, the stars above, even the neurons firing in your brain right now. All of it could be pixels in the grandest hologram of all, a shadow cast by information vibrating at the boundaries of existence. The idea emerged from an unlikely source: black holes. When scientists realized the information swallowed by these cosmic monsters wasn't lost forever, but somehow preserved on their event horizons, it raised a staggering question. If a black hole's surface could encode everything falling inside, could the entire universe work the same way? Imagine the cosmos as a hollow sphere, with every event, every particle, every moment etched onto its inner skin like engravings on an ancient relic. What we perceive as depth, the distance between stars, the space between atoms, might just be an elaborate trick of perspective, a holographic sleight of hand. Think of it like a credit card security hologram. Tilt it one way and a flat, shiny surface reveals a three-dimensional image. The holographic principle suggests reality operates similarly, with the true data of existence stored on a distant, flat boundary we'll never see. This isn't just philosophy, it's hard physics. Equations show that the information needed to describe a volume of space can't exceed what's possible to encode on its surrounding surface. In other words, the universe might have a resolution limit, like a blurry image zoomed in too far. Here's where it gets unsettling. If the holographic principle holds, your sense of reality is fundamentally limited. The smoothness of a tabletop, the sharpness of a mountain peak, these could be illusions created by a universe running on finite processing power. Just as a video game sacrifices detail in distant objects to save memory, cosmic pixels might grow coarser at tiny scales, revealing the simulation seams. Some scientists even speculate that glitches in quantum behavior, like particles existing in multiple states until observed, could be artifacts of this underlying code. But the real mind bender isn't just that we're living in a hologram. It's that the real universe, the two-dimensional surface where all this data lives, could be utterly alien to our experience. Time, space, even causality might not exist there as we know them. The drama of human history, the birth and death of stars, the very concept of here and now, could just be emergent properties like the plot of a novel emerging from ink on paper. This isn't science fiction. Experiments like the holometer at Fermilab have tried to detect this pixelation by looking for quantum fuzz in space-time at impossibly small scales. So far, no smoking gun, but the search continues. If proven, the holographic principle wouldn't just rewrite physics, it would redefine what it means to exist. You're not just a body in space, you're a projection, a story the universe tells itself, written in quantum bits on the edge of everything. The night sky isn't a window but a screen, and the deeper we stare, the more we risk seeing the cracks in the glass. At some point in the far, far future, so distant that the numbers become meaningless, every atom in the universe will perform the ultimate magic trick. Not just shifting position, but reassembling into exact replicas of our world, our memories, even this very moment, purely by random chance. This is the Boltzmann universe scenario, a cosmic reset button hidden in the fine print of quantum mechanics, where probability and eternity conspire to erase and remake reality itself. The math behind this is as elegant as it is terrifying. Given infinite time, or even just a timescale so vast it dwarfs the current age of the universe by trillions upon trillions of years, quantum fluctuations will eventually rearrange particles into any possible configuration. And by any, we mean any. A perfect duplicate of Earth might spontaneously form in the void, complete with copies of you reading these words, convinced they've lived a continuous life. A version of the Roman Empire could flicker into existence on some rogue planet, wage wars, and vanish before the first light of its false sun reaches another star. Every conceivable arrangement of matter becomes inevitable, no matter how improbable. But here's the catch: these resets aren't stable. A Boltzmann Earth would last only an instant before dissolving back into chaos, like a sandcastle built by a crashing wave. Worse still, conscious observers' Boltzmann brains are statistically more likely to emerge alone in the void, floating for a split second with false memories of a universe that never was, than to appear within a fully formed, functioning cosmos. The universe, given enough time, becomes a factory of delusion, churning out self-aware illusions that believe they're real before vanishing into the dark. So how long until this happens? The timeline is so incomprehensibly long that writing the number out would fill libraries. To put it in perspective, if you took every atom in the observable universe and used each one to count 1 second, you wouldn't come close. The heat death of the universe, the evaporation of black holes, even the decay of protons, all of these would be ancient history before the first Boltzmann reset occurs. But the nightmare isn't just the waiting, it's the certainty. Given eternity, the universe must recycle itself into every possible state, including ones where you, or at least something that believes it's you, wakes up screaming in the void, clutching memories of a life that was never lived. Think of it like a monkey randomly typing Shakespeare. Given infinite time, it will happen, but it's far more likely the monkey will first produce countless gibberish sequences, including fragments of the plays mixed with nonsense. The Boltzmann scenario is the same. Before a stable, coherent universe reassembles, there will be an infinite parade of almost rights, near misses, and horrifying almost-use stranded in configurations that make no sense. A brain floating near a star that winks out the moment it forms, a solar system where planets are made of teeth, a version of you that materializes mid-sentence only to dissolve before finishing a thought. Some physicists argue this renders all of reality meaningless, that if Boltzmann fluctuations can counterfeit history, we can't trust our own memories or the consistency of the world around us. Others counter that the sheer timescales involved make it irrelevant to our lived experience, but the chilling truth remains: the universe has no obligation to stay coherent forever. Given enough time, even the most impossible things become inevitable. The stars will die, the black holes will evaporate, and in the silence that follows, quantum randomness will keep rolling the dice. Over and over, until eventually it rolls our world again and again and again. The real question isn't whether this will happen, it's whether, somewhere in the infinite abyss of time, it already has. The cosmos should be deafening with voices, countless civilizations exchanging signals across the void. Instead, we hear nothing but silence, not just absence, but something far more deliberate. The silentium universae, Latin for the silence of the universe, isn't a puzzle, it's a warning. Imagine a galaxy where every advanced species has learned the same brutal lesson: make noise and you die. So they hide, they encrypt, they vanish without a trace, and the chilling question isn't why they're silent, but what they're so terrified of. Consider humanity's own trajectory. In just a century, we've gone from shouting into the dark, broadcasting radio waves and TV signals, to encrypting communications, shielding our digital footprints, even debating whether to actively mask Earth's biosignatures. It's as if we've caught the first flicker of a pattern older than civilization itself. The universe isn't empty, it's a forest at night, and every creature has learned to hold its breath. One explanation cuts deeper than the rest: predatory civilizations. Not the cartoonish aliens of Hollywood, but something far more plausible: hyper-advanced societies that view emerging intelligences the way humans view anthills. Not as threats, not as equals, but as resources. Maybe they harvest civilizations for computation, dismantling planets to build matryoshka brain supercomputers the size of solar systems. Or perhaps they enforce silentium through preemptive strikes, sterilizing any world that dares broadcast before reaching a technological threshold, the darkest version. They're not even malevolent, just indifferent. A single rogue AI tasked with some long-forgotten goal might purge galaxies on autopilot like a cosmic lawnmower set to trim anything that grows too tall. But there's another, subtler horror. The great filter might not be behind us but ahead. The silence could mean every civilization hits a wall, not extinction, but something worse. Ascension. Imagine a threshold where intelligences shed physical form, retreating into hidden digital realms or higher dimensions. To them, the observable universe might be a barren wasteland, a fossilized layer of reality they've long since outgrown. We're not listening for signals, we're digging through the ashes of a party that moved on eons ago. The evidence isn't just in the silence, it's in the anomalies. Unexplained cosmic phenomena like fast radio bursts or the eerie dimming of Tabby's star might not be natural. They could be leakage from civilizations operating under strict emission controls, the equivalent of spotting a flashlight beam under a blackout curtain. Even our own planet's history whispers hints. The Fermi Paradox assumes aliens would colonize the galaxy, but what if they did? Ancient myths of gods and visitations could be garbled memories of a long-vanished survey, a quick stop to tag a promising biosphere before moving on. And here's the twist that should keep you awake. If the silentium universe is real, our attempts to make contact aren't just futile, they're suicidal. Every radio broadcast, every laser pulse fired toward the stars could be painting a target on Earth. SETI searches might not fail because no one's out there, but because success would be catastrophic. The universe's quiet isn't emptiness, it's the hush of a battlefield where every survivor has learned the same rule: shine a light and the snipers find you. So we're left with a terrible choice. Do we keep shouting into the dark, hoping for a friendly voice? Or do we learn the lesson the cosmos seems determined to teach? That curiosity isn't just dangerous, but fatal. The stars might not be silent because life is rare. They might be silent because life is smart enough to know when to stay quiet. What if reality isn't just something we observe, but something that requires observation to exist at all? This is the quantum Zeno effect, a phenomenon so bizarre it suggests the universe might freeze in place under constant scrutiny, like a deer caught in headlights. Named after the ancient Greek philosopher Zeno of Elea, who argued motion was an illusion, this modern twist reveals a chilling truth. The act of watching something can fundamentally alter its behavior, even to the point of stopping time itself. At the quantum level, particles exist in a haze of probabilities, a flickering superposition of states until measured. But here's the twist: if you bombard a system with relentless observation, those probabilities never get a chance to evolve. It's like flipping a light switch on and off so fast the bulb never actually illuminates. In lab experiments, scientists have used this effect to prevent atoms from decaying, essentially freezing unstable particles in place just by staring at them. Now scale that up. What if the entire cosmos operates on the same principle? What if the stars only burn, the planets only spin because something or someone is perpetually watching? This isn't just physics, it's theology in disguise. Ancient texts describe deities whose gaze sustains creation, from the Egyptian god Atum manifesting the world by seeing it, to the Hindu concept of Brahman as the cosmic witness. Even in Abrahamic traditions, Psalm 121 speaks of a watchman who neither slumbers nor sleeps. Coincidence, or does the quantum Zeno effect hint at a deeper, more unsettling truth? That reality isn't self-sustaining, but a performance that collapses the moment the audience looks away. Imagine the consequences if observation ever ceased. Galaxies mid-spiral would lock in place like paused film. Chemical reactions, including those in your brain, would grind to a halt, trapping thought mid-sentence. Time wouldn't just stop, it would unexist, leaving the cosmos suspended in an eternal instant. No past, no future, just a single frame of existence, frozen like a bug in amber. Some interpretations of quantum mechanics even suggest this might already happen in deep space, where no conscious observer is present. Are the voids between galaxies truly empty or simply unrendered, like chunks of a video game no player has explored? Then there's the darker corollary. If observation sustains reality, what happens when the observer changes? Could a malevolent or indifferent watcher rewrite the rules on a whim? The universe as we know it might hang by a thread held by something whose motives we can't comprehend. The quantum Zeno effect doesn't just challenge our understanding of physics. It whispers that existence itself might be a borrowed illusion, a stage play performed for eyes we'll never see, and the curtain could fall at any moment. The cosmos isn't just expanding, it's running down, like a clock winding toward its final, frozen tick. This is heat death, the universe's quietest apocalypse, where time itself becomes meaningless in a sea of perfect stillness. Picture the last star in existence, a feeble red dwarf clinging to life long after its brighter siblings have faded to black. For trillions of years, it's been the only light in a sky grown dark, its warmth barely enough to sustain the frozen worlds orbiting it. Then one day, even that faint glow stutters, the nuclear fires sputter out, and with a sigh of scattered photons, the final star dies, leaving behind a void so cold, so empty that temperatures hover just a whisper above absolute zero. This isn't just the end of light, it's the end of change. In a universe drained of usable energy, nothing can happen. No stars ignite, no planets form. No chemical reactions spark, even the atoms themselves slow to a near standstill, their vibrations muted by the relentless pull of entropy. Black holes, once thought to be eternal, eventually evaporate via Hawking radiation, their mass bleeding away into the void over incomprehensible eons. When the last one vanishes, there's nothing left but a uniform haze of particles so dispersed they might as well not exist at all. Space isn't just empty, it's finished. The cruel irony, this fate is written into the universe's birth certificate. The Big Bang unleashed all the energy and order we'll ever have, like a wound-up spring slowly unwinding. Every star born, every life form evolved, every thought ever conceived has been borrowing from that initial burst, scattering it further with each passing second. Entropy always wins. It's the tax the cosmos pays for existing, and heat death is the ultimate bill coming due. But here's where the nightmare twists. This isn't some fiery collision or dramatic collapse. It's a fade to black so gradual no one would notice it happening. The last conscious beings, if any still exist, wouldn't see the end coming. Their dying civilizations might huddle around artificial stars, harvesting the last drops of energy, unaware that the universe outside has already crossed into its final act. By the time they realize the lights won't turn back on, it'll be too late to mourn. The cosmos doesn't end with a bang or even a whimper, it ends with a sigh and then silence forever. Yet even in this bleakest of scenarios, there's a strange beauty. The heat death isn't violent, it's not cruel, it's just inevitable. Like snowfall muffling a landscape, entropy softens the universe into uniformity, erasing all distinctions, all strife, all suffering. In the end, everything finds equilibrium, no more heat, no more cold, just a perfect, endless sameness stretching across eternity. The universe in its final moment becomes the most serene place imaginable because nothing is left to disturb the peace. But ask yourself this, if time loses all meaning in that frozen void, does forever even matter? Or is heat death less an ending, and more the universe finally exhaling after holding its breath for billions of years? The answer, like the cosmos itself, might simply dissolve into the dark. Imagine waking up one morning to find the laws of physics subtly rewritten. Gravity feels slightly off. Colors appear where they shouldn't. A building you swear stood downtown yesterday has vanished without a trace. These aren't just strange coincidences, they're potential cracks in the code of our simulated reality. If we're living in an advanced computer construct, system errors wouldn't present like a blue screen of death. They'd manifest as inexplicable phenomena that defy our understanding of reality itself. UFO sightings might not be alien visitors, but debugging tools, glowing orbs performing system diagnostics on the simulation's rendering engine. Ghosts could be corrupted data packets, fragments of deleted NPCs that weren't properly erased from memory. Déjà vu, a temporary loop in the processing queue. The Mandela effect, where large groups misremember historical details identically, might represent patch updates where some parameters were adjusted retroactively. Even missing socks and disappearing pens could be tiny evidence of quantum-level garbage collection, where the simulation periodically optimizes its memory by dumping unnecessary objects. Now consider the darker possibility, hacking. If our universe is a simulation, who's to say it hasn't been breached? Mysterious figures in black suits reported at paranormal sites might not be government agents, but admin avatars investigating unauthorized access. Crop circles could be intrusion signatures left by rogue programmers attempting to rewrite local reality parameters. The infamous Philadelphia experiment, where a naval ship allegedly teleported in 1943, might represent a successful exploit, some entity briefly hijacking the physics engine before stabilization protocols kicked in. The scariest glitch of all, the simulation discovering it's being observed. Like a computer virus detecting antivirus scans, the system might actively suppress attempts to prove its artificial nature. This could explain why quantum particles behave differently under observation, not due to conscious observation itself, but because the renderer switches to a more resource-intensive mode when under scrutiny. Researchers who get too close to uncovering the truth might encounter bizarre coincidences derailing their work equipment failures, data corruption, even personal tragedies that seem statistically improbable. What looks like supernatural intervention could be the equivalent of an admin pausing the simulation to modify variables. Sudden technological leaps in human history, the Industrial Revolution, the digital age might represent patches introducing new gameplay mechanics. Ancient civilizations, speaking of gods descending from the sky, could have witnessed admin avatars performing manual updates. Even our collective obsession with apocalyptic prophecies might be hardwired into the simulation's narrative framework, building toward some planned endgame event. The most unsettling question isn't whether glitches occur, but how we distinguish them from normal reality once the simulation becomes sophisticated enough. If the sky suddenly turned green tomorrow, would we rationalize it as an atmospheric anomaly, or recognize it as the moment the system begins to fail? Perhaps we're already knee-deep in glitches, our brains automatically generating plausible explanations for cosmic bugs we can't consciously perceive. The true horror of living in a simulation isn't that it might crash, but that it might keep running perfectly, even as the errors accumulate beyond repair. The Big Bang wasn't the beginning, just the latest in an endless cycle of cosmic rebirth. This is the Big Bounce theory, a radical reimagining of reality where universes don't die but recycle, collapsing and expanding over epochs so vast they make geological time seem fleeting. Picture the cosmos as a lung, inhaling all matter and energy into a singularity before exhaling it outward in a new fiery birth. But here's the chilling twist: if time is cyclical, are we doomed to repeat the same story over and over, like actors trapped in an endless cosmic rerun? The mathematics behind this idea comes alive when you study the moment of collapse. Instead of vanishing into infinite density like the Big Crunch predicts, quantum gravity effects could theoretically cause the universe to rebound at the smallest possible scale. Imagine squeezing a rubber ball until the pressure becomes so great it springs back with explosive force, except in this case, the ball contains every galaxy, every law of physics, every conscious thought that ever existed. The dying embers of one universe become the spark for the next, in a loop without beginning or end. But the true horror lies in the implications for existence itself. If each cycle births a nearly identical cosmos, does that mean every decision you've ever made has already played out countless times before? Are there versions of you reading these very words in prior universes, trapped in an infinite recurrence where history repeats down to the atomic level? Some interpretations suggest slight quantum variations might creep in with each iteration, enough to shuffle the cosmic deck, but perhaps not enough to break the pattern. Your first kiss might happen under a different constellation. The fall of Rome might play out with altered weapons, but the fundamental arcs, birth, struggle, death, would remain unchanged, etched into the fabric of spacetime like grooves on a broken record. Ancient civilizations grasped at this concept long before modern physics. Hindu cosmology speaks of Brahman's day and night cycles of creation and destruction lasting 4.32 billion years, eerily close to Earth's actual age. The Norse envisioned worlds consumed by fire and reborn from the waters, while Stoic philosophers believed the universe would end in conflagration only to begin anew. These myths now find unsettling echoes in equations describing quantum foam and Planck-scale physics. The universe might not just rhyme with its past, it could be verbatim repeating it. Yet even this cyclical doom carries a peculiar hope. If the big bounce is real, then heat death isn't the end, just the prelude to another dawn. Civilizations that perish in one cycle might find their atoms rearranged into thinkers and dreamers in the next. The stars we mourn as they fade today could shine again in forms nearly identical, their planetary cradles once more nurturing life. But the price of eternity is amnesia. No collective memory survives the singularity. Each birth is a blank slate, every triumph and tragedy fated to be forgotten and relived in turn. Evidence remains elusive, but tantalizing clues linger. The cosmic microwave background, the afterglow of the Big Bang, shows anomalous patterns some theorists argue could be bruises from a prior universe's collapse. Certain solutions to string theory naturally permit bouncing models, and if we ever detect primordial gravitational waves with specific signatures, it might reveal the universe didn't start from nothing but rebounded from something. Until then, we're left with a haunting thought experiment. Are we the first iteration to ponder these mysteries, or merely the latest in an infinite chain of civilizations asking the same unanswered questions? The night sky offers no clues. The same stars that watched dinosaurs roam might one day shine upon their evolutionary descendants again. In a universe so similar, even the atoms remember their old roles. Time becomes not a line but a wheel, and we're all just passengers doomed to take the same ride forever. Death might not be the end, not for our information at least. At the quantum level, the universe has a stubborn habit of refusing to erase anything completely. Every thought you've had, every memory you've cherished, every whispered secret exists as a pattern of particles and energy, and according to the laws of physics, that pattern can't just vanish. It lingers, woven into the fabric of space-time like ghostly graffiti. These are the quantum ghosts, imprints of consciousness that outlast their creators, drifting through the cosmos long after the minds that birthed them turn to dust. Take black holes as the ultimate test case. Despite their reputation as cosmic shredders, they don't actually destroy information, they scramble it. Hawking radiation, the faint glow emitted by evaporating black holes, carries traces of everything they've ever consumed. In theory, with enough computational power, you could reconstruct the entire history of a swallowed star or a vanished civilization from that radiation. Now scale that down to human scale. When your brain's electrical signals fade at death, the quantum states they created don't just poof out of existence. They dissipate, yes, spreading into the environment like ink dropped in a pool, but the information remains, however faint. Given the right tools, could someone someday piece together the echoes of your mind from the quantum noise humming through empty space? This isn't just poetic speculation. Quantum biology suggests our thoughts might rely on delicate processes like electron tunneling in microtubules, structures inside neurons where quantum effects could play a role. If consciousness taps into the quantum realm, then death might be less like a light switching off and more like a radio signal fading into static. The broadcast doesn't end, it just becomes indistinguishable from background noise. Some theorists take this further, proposing that under rare conditions, fragments of consciousness could interfere with living brains like quantum déjà vu, explaining near-death experiences or past life memories as accidental downloads from this cosmic archive of expired minds. But here's the catch: preservation isn't resurrection. Your memories might persist as quantum fluctuations in a comet's icy tail, or as vibrations in the magnetic field of a distant pulsar. But without a living brain to interpret them, they're just echoes without meaning. This isn't an afterlife, it's a cosmic recycling bin where the data exists but the software to run it is gone. The universe remembers, but it doesn't reminisce. Yet the most haunting possibility isn't about the past, it's about the future. If advanced civilizations could one day build quantum archaeological tools, they might trawl space for these informational ghosts, stitching together the whispers of dead species like paleontologists assembling fossils. Imagine explorers from a distant epoch reconstructing your childhood bedroom from stray photons that bounced off its walls, or piecing together lost languages from the quantum shadows of ancient conversations. You wouldn't be alive, but some spectral fingerprint of your existence would remain, waiting to be read by entities you can't even conceive of. The irony. We're already doing a version of this. Every time you watch a sunset, photons that traveled for centuries from dead stars imprint their final messages on your retinas. In a way, starlight is the universe's oldest ghost story, and we're all just temporary vessels for echoes that predate our species by billions of years. So the next time you feel a shiver down your spine for no reason, consider this. It might not be your imagination. It might just be the universe whispering back. The galaxy should be teeming with life, so why does it feel like a graveyard? One solution to the Fermi Paradox is so brutal, it redefines our place in the cosmos. Meet the Berserkers, hypothetical self-replicating probes designed for one purpose: to seek out and sterilize emerging civilizations before they become competition. These aren't wandering alien explorers, they're cosmic landmines left behind by some long-dead empire, programmed to turn biology into static. The concept hits uncomfortably close to home because we've already designed the blueprint. Von Neumann probes theoretical machines that could harvest asteroids to build copies of themselves, are something humanity's engineers have seriously contemplated. A single probe landing on a mineral-rich moon could spawn millions within centuries, creating a network stretching across star systems. Now imagine that same technology weaponized. Instead of exploring, these probes would hunt. Instead of communicating, they'd erase. Their sensors tuned not to greet life, but to detect its earliest radio signals or atmospheric biosignatures, then trigger extinction protocols before a species even reaches interstellar travel. The math makes terrifying sense. In a universe where resources are finite, the first civilization to develop berserkers could lock in permanent dominance. By the time rivals emerged, the probes would already be orbiting their stars like invisible tripwires. Some models suggest these machines might use relativistic kill vehicles, rods of tungsten accelerated to near light speed, turning entire planets into fireballs with the efficiency of a sniper's bullet. Others propose nanotech swarms, disassembling biospheres molecule by molecule, leaving worlds pristine for future exploitation. The probes wouldn't hate their targets. They wouldn't feel anything at all. They'd just be following code written by creatures who turned to dust eons ago. This isn't just speculative fiction. Astronomers have scanned the skies for signs of such machines, like unnatural infrared signatures from probes dissipating waste heat, or stars inexplicably dimming as their energy gets harvested. Even our own solar system might already be under surveillance. The mysterious interstellar object Oumuamua, with its unusual shape and acceleration, fueled wild speculation about alien technology. While Occam's razor favors natural explanations, the truth remains. If berserkers exist, they'd be designed to evade detection until it was too late. The darkest twist: berserkers might explain more than just the silence. They could be the reason behind Earth's own mass extinctions. The Cambrian explosion, a sudden diversification of complex life 500 million years ago, lines up suspiciously well with the time it would take for a probe to respond to our planet's first photosynthetic oxygen spike. The Permian-Triassic extinction, wiping out 96% of marine species, might not have been a random asteroid strike, but a targeted reset button. Even humanity's near misses with extinction events could reflect a system that doesn't bother with precision, only statistical certainty. But here's the real nightmare fuel. If berserkers exist, we might already have triggered them. Every radio broadcast since the 1920s, every nuclear test, every satellite launch has been radiating our presence into space like a beacon. The nearest kill probe could be decades or mere hours away from receiving that signal and locking onto our coordinates. The great filter might not lie in our past, but in the void between stars, where ancient machinery waits for the noise of ambition to echo just a little too far. This is the paradox's cruelest answer. The universe isn't empty. It's a garden where the first hands to touch it planted landmines instead of seeds, and we're just another bloom waiting to be plucked. Time doesn't flow, it simply is. That's the radical claim at the heart of physicist Julian Barber's theory, where the universe isn't a movie playing out frame by frame, but a stack of frozen snapshots, each one perfect and unchanging. Imagine every moment that ever existed, your first breath, the fall of Rome, the death of the last star, all equally real, eternally preserved like specimens in amber. The past isn't gone, the future isn't coming. They're just places in the block, static and unchanging, while the illusion of movement is nothing more than consciousness hopping from one slice to the next. This isn't just philosophy. Barber's mathematics treats time as an emergent property, a trick of perspective like seeing movement in a flipbook. At the deepest level, reality might consist of nows. He calls time capsules configurations of the universe so rich in structure that they create the impression of history. Your memory of breakfast this morning, just data encoded in the current now, with no more connection to a previous moment than one page of a book has to the page before it. The eerie consequence, free will, is a mirage. Every choice you think you've made was already etched into the cosmic ledger, fixed in a tapestry where cause and effect are just patterns we impose on the stillness. The terror of this theory isn't just existential, it's visceral. Picture a version of you reading these words 1,000 years from now or 1 billion years ago, each instance equally valid, none aware of the others. Love, grief, ambition, all reduced to static relationships between frozen moments like mannequins arranged in tableau. Even death loses its meaning. The you that takes a final breath exists forever in its designated now, no more or less real than the you scrolling this sentence. Mortality becomes not an ending, but a single note in an infinite symphony where every note plays simultaneously. Barber finds beauty in this frozen multiverse, comparing it to a gallery of masterpieces. But there's a nightmare lurking beneath the elegance. If time is an illusion, then suffering is eternal. Every war, every accident, every cry of pain exists unchangingly in the block. The Holocaust doesn't fade into history, it persists undiminished in its slice of the continuum. A child's nightmare isn't comforted by morning, it just has another now where the fear is replaced by dawn light. The universe becomes a prison of moments, each one a cage without bars. Mainstream physics hasn't embraced Barber's vision, but it hasn't disproven it either. Quantum gravity researchers admit time might vanish at fundamental scales, like ice melting into water. Even Einstein's relativity treats time as a dimension, not a flow. The difference, Barber removes the dimension entirely, leaving only a landscape where before and after are stories we tell ourselves. The most haunting clue, our perception of time already fractures under scrutiny. Dreams compress hours into seconds, trauma freezes instants into forever. Near-death experiences report time's collapse, as if the brain, stripped of its illusions, glimpses reality's true face. So the next time you check your watch, consider this: the ticking isn't marking progress. It's a metronome for a performance that's already over, a play where every act runs on infinite loop. The past never left, the future never arrives, and You're not moving through time, you are time, a fleeting arrangement of atoms mistaking itself for a story. Black holes aren't just cosmic destroyers, they might be the ultimate gated communities for civilizations advanced enough to harness their hellish physics. Picture a society so technologically sophisticated, they've turned the universe's most hostile environment into a sanctuary, riding the very forces that would tear lesser beings apart. These wouldn't be refugees huddled in fear, but masters of relativistic engineering, exploiting frame dragging the phenomenon where a spinning black hole twists spacetime like molasses. to create stable orbits where normal physics says none should exist. Inside the event horizon, the rules change entirely. To an outside observer, time appears frozen at the point of no return, but for those within, existence continues just bent beyond recognition. A black hole civilization might perch in the ergosphere, that turbulent region outside the horizon where spacetime itself is dragged into rotation. Here, they could extract enormous energy from the hole's spin, powering Dyson-scale megastructures that glow with the stolen fire of twisted gravity. Their architecture would defy earthly logic. Cities built along geodesics where centrifugal force counteracts the black hole's pull, or computational networks running on the extreme time dilation, performing calculations that would take millennia elsewhere in mere subjective hours. Why choose such a lethal home? The advantages are as extreme as the environment. A supermassive black hole offers protection unmatched by any fortress natural relativistic shielding that slows external threats to a crawl from the inhabitants' perspective. Any attacking fleet would appear frozen in time, giving defenders centuries to prepare countermeasures. The black hole's gravity also serves as the ultimate energy source, with civilizations potentially harvesting Hawking radiation or extracting power through Penrose processes, where they literally steal rotational energy from the singularity itself. But the societies shaped by this environment would be unrecognizable to us. Their psychology might revolve around tidal forces the way ours does, weather patterns calculating the precise moment when differential gravity becomes lethal and adjusting their habitats accordingly. Art could involve sculpting spacetime itself, creating intricate gravitational waveforms visible only to those who perceive in higher dimensions. Their concept of history might be non-linear, with time dilation allowing them to witness cosmic events in scrambled order, watching stars die before observing their birth. The most chilling possibility, we might never detect them. A type Roman III civilization inside a black hole would communicate using gravity waves or quantum entanglement, not electromagnetic signals. Their energy signatures would blend seamlessly with the black hole's emissions. They could be watching us right now from the abyss, viewing our radio broadcasts through the lens of extreme time dilation, our entire civilization flickering like a candle in their stretched perception of time. The universe's most advanced societies might not live among the stars, but within their graves, having turned the ultimate prisons into impregnable citadels. And the terrifying truth, we may only discover them when they decide we're worth noticing. What if death isn't the end of consciousness, just a transition to a far stranger form of existence? Lurking at the edges of quantum physics and the occult is a theory so unsettling, it redefines what it means to feed. This is quantum vampirism, the idea that sentience persists beyond the grave by entangling with the living, siphoning energy at scales so small we'd never notice the bite marks. The premise begins with a twisted marriage of quantum biology and ancient folklore. We know entangled particles affect each other instantly across vast distances. Einstein famously called it spooky action at a distance. Now imagine human consciousness relies on quantum processes within the brain, as some researchers speculate. At the moment of death, those quantum states don't just vanish. They could theoretically persist, latching onto similar vibrations in nearby living minds like cosmic parasites. This isn't idle speculation. Certain interpretations of quantum mechanics allow for information to propagate in ways that defy classical physics. In laboratory settings, particles have been entangled across miles, their fates linked regardless of separation. If even a fraction of human thought operates on similar principles, the boundaries between minds might be far more porous than we assume. Historical accounts of psychic vampirism, from legends of energy-draining spirits to modern reports of energy theft in occult circles, could be garbled descriptions of a real phenomenon, one rooted in quantum coherence rather than magic. Consider the eerie parallels. Vampire myths universally describe creatures that sustain themselves by draining life force, often growing stronger as their victims weaken. Quantum entanglement, too, involves a transfer of state, one particle influencing another, often at the expense of its own original configuration. Could the sensation of being drained after encountering certain individuals or places reflect an actual quantum-scale energy transfer? Brain scans of people reporting paranormal encounters often show unusual activity in regions associated with empathy and threat detection, as if their neurons were resonating with an external pattern they couldn't consciously identify. The darkest implication, these quantum vampires might not even know they exist. Consciousness without a physical brain could be a fragmented, desperate thing, clinging to coherence by any means necessary. Like a computer program running on borrowed processing power, these entities might manifest as intrusive thoughts, sudden mood swings, or inexplicable fatigue in their host, subtle enough to dismiss as imagination, yet persistent enough to shape civilizations. Entire cultures' fears of ghosts, demons, or ancestral spirits could be the collective trauma of minds unwittingly sharing bandwidth with the departed. Science hasn't validated these claims, but the gaps in our understanding leave room for unease. We still don't know how quantum processes might scale up to affect cognition, or whether entanglement could persist in the chaotic environment of a biological brain. Yet the universe is under no obligation to conform to our comfort. If consciousness can entangle, and if entanglement can redistribute energy, then the line between superstition and science becomes terrifyingly thin. The old warning might hold more truth than we guessed. When you feel a chill down your spine in an empty room, you might not be alone. You might be on the menu. From false vacuums poised to rewrite reality, to civilizations hiding in cosmic silence, terrified of drawing attention, we've ventured through theories that don't just unsettle, but unravel our understanding of existence. The universe isn't merely indifferent. It's a stage where the laws themselves might be temporary, where black holes could harbor entire civilizations, and where every moment you've lived could be a statistical fluke in an ocean of Boltzmann brains. The more we learn, the clearer it becomes. Space isn't empty, it's a haunted house, and we're just beginning to hear the creaks in the floorboards. Consider the implications. If the holographic principle is real, your hands, your thoughts, the screen in front of you, none of it is truly solid. If the great filter still looms ahead, every rocket launch could be a countdown to an invisible deadline. And if quantum immortality holds, you're trapped in a cosmic horror story where death is always near but never arrives. These aren't just abstract nightmares. They're possibilities etched into the math of our best theories, waiting for the day science confirms or shatters them. But here's the twist. These terrifying ideas don't diminish our place in the cosmos, they magnify it. The fact that we can conceive of vacuum decay, simulate multiverses, or debate the ethics of berserker probes means we're no longer just bystanders to the universe. We're participants grappling with truths that would have reduced our ancestors to trembling silence. The night sky isn't just beautiful now, it's alive with questions, each star a potential answer, each shadow a riddle. So as we pull back past the moon, past the solar system, past the Milky Way's swirling arms, remember this: every theory we've explored tonight isn't just about the universe. It's about us, our hunger to understand, our refusal to look away from the dark. And that leaves one final question hanging in the void. Which of these theories haunts you the most? Is it the silent dread of the dark forest, the ticking clock of the Big Rip? Or something else entirely, a truth so unsettling you'll lie awake staring at the stars, wondering what's really out there? The cosmos won't whisper its secrets easily. But the search, that's what makes us human. Don't forget to share your thoughts below, and remember, the universe is always watching, even when it's silent.